Hey, another good morning, neighbors. So, mentioned before about signal to noise thingies. Let's call them ratios, right? Because when the crowd is too big and you can't hear the artist, the noise ratio is too high. The signal is lost in the noise. Um, your local community is in a high traffic area, and there's a constant background noise. So there's a low background, just it's always there. Some people notice it, some people don't. Some people notice it's worse on a foggy day than a clear day, or it's better, or something. So signal to noise ratios. I was introduced to these, just to preface, learning radio theory, radio systems, radio wave transmissions, and how they propagate. So how the noise would be introduced to what is a clean signal from the transmitter. How the receiver on the other end can pick that noise up and the signal up and cancel out the noise so you can hear me speaking clearly. You don't hear the ringing in my ears. You don't hear my receding hairline. Slowly though. And my hair is exhibiting the chaos theory. You're welcome. So, signal to noise. You have to kind of think there's a signal there to go looking for it among the noise. That's something like the SETI project. We hear noise from the universe day in and day out. And we've gotten better at hearing it with the instruments and the telescopes and the smelloscopes and all the new things we're going to invent. So, signal processing has discrete areas, visual, right, what you see, audio, what you hear, temperature. Even that's signal processing. It's a little bit slower. It takes a minute to realize you're burnt. For that signal to reach past the skin it's burning into the nerve cells near the surface of that skin, right? That's signal processing. Signal to noise. The heat is something different than the normal air around you, so you're noticing a difference. Discrete signal processing. So that could lead, DSP, discrete signal processing, can lead into control systems architecture. A SCADA system for pipeline monitoring out there in one industry. Distributed control system. Highly available distributed control system down the street doing something else. Same things, different acronyms for what they're doing. So signals to noise. In radar, you have to understand this even better, because radar sends a signal out and it gets reflected off something and has to come back. So you have noise introduced in both directions. Noise that you've got to be able to identify and zero out. Change the 0 to 2. So 2 is, this is, makes you think kind of stuff. So the noise in a signal has to be subtracted for these radar systems, for the radio systems, for your radio to work. Go back and look for crystal radios. That was my first introduction, making a crystal radio when I was, that big. Batteries not included because you didn't need them. And you still don't for AM signals. So that's an interesting one to do with someone younger than you. Put that on your list. But the noise around that signal, how do you subtract that noise? Previous video I discussed A to D converters, analog to digital signal converters, where you take a signal out there and you make it into a digital number for processing. So a computer can be turned loose on it. Computer just, it's a number, has no idea. Has no idea unless you program some learning intelligence, it can learn about the number. But if you just gave the computer the number, it's a number. So on the input side of that A to D, you're going to have filter systems of some sort, mechanical filters, let's call them, because they're electrical, they're electronic, they're not digital. That's in the front end of the signal. You have to know what the signal is and know what the noise is that you can remove from the signal. So the computer hasn't even seen the noise. It knows nothing of the noise because you subtracted it from the signal. But you know about the noise. So in your software, when you go use that number on the other side of the computer divide, you've got to keep the relationships. The numerator and the denominator have to stay along with that number so that you can understand what it means. So that on the front side of that digital to analog converter, that little amazing microchip that takes 0 to 100 volts and converts it into a number. That's all it does. It's its whole life, its whole existence. It's its meaning, its special purpose is to convert. But it's in an ecosphere that supports it's doing its thing. It converts numbers. And the whole circuit board around it supports its efforts in the number gathering because no chip is alone. So this field is, let's save it for the 301 coursework. Peace out.